Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we'll be looking at previous year questions of mathematics in various engineering entrance exams in India. Today we're dealing with the chapter Vector Algebra. So this chapter is about the vector multiplication, vector properties, and as well as vector functions. So we're going to be looking at what is a vector, how do we represent a vector, the different components of a vector, and the different operations that go along with it. So without further ado, let's look at the first question of this episode. So this was asked in 2002. If modulus of vector A is 4, modulus of vector B is 2, and the angle between A and B is pi by 6, then find the value of vector A cross vector B the whole square. So this question, although it looks complicated, is comparatively simple. What you need to do is you need to use the formula for A cross B. So that is equal to modulus of vector A, modulus of vector B, and then sine theta. You multiply these three terms, you get A cross B, or mod of A cross B. So now let's put in the values. So over here, modulus of vector A is 4, modulus of vector B is 2, and sine theta will be sine of pi by 6. So that means 4 times 2 times 1 by 2. So 2 and 1 by 2 gets cancelled. So therefore 4 is the value of mod of A cross B. So therefore the square of A cross B mod will be equal to 4 square, which is equal to 16. So therefore the correct answer is option B. So option B, 16, is the correct answer for this question asked in 2002. Let's look at the next question. If vector A, vector B, and vector C are vectors such that vector A plus vector B plus vector C is 0, then you need to find the angle between the vector B and C. So this is a slightly tricky question, and we're going to be using the values present in the question. So over here you can see that vector A plus vector B plus vector C equals 0. So that means we will write vector B plus vector C as negative of vector A. Now what we're going to do is we're going to square this on both sides. So when you're squaring on both sides, you will get modulus of vector B the whole square plus modulus of vector C the whole square plus 2 times modulus of vector B times modulus of vector C, which is equal to modulus of minus vector A the whole square. So here we use A plus B the whole square formula, and here we use the general square. So over here, modulus of minus of vector A is the same as modulus of vector A, so that will give you, so you just need to apply the value of mod of vector A equals 7, and then you need to apply mod of vector B equals 5 and mod of vector C equals 3. So when you put it according to the formula, you get 5 square plus 3 square plus 2 into 5 into 3 times cos theta. Now cos theta is a variable here, and we need to find that. And on the right hand side, it's mod of vector A the whole square, so that means it'll be 7 squared. So therefore you have 25 plus 9 plus 2 times 5 is 10, 10 times 3 is 30, 30 cos theta equals 49. So now 30 cos theta will now be equal to 49 minus 9 minus 25. So 49 minus 9 is 40, 40 minus 25 is equal to 15. So 30 cos theta equals 15, So that means cos theta equals 15 by 30. And since 15 goes into 32 times, the right hand side will become 1 by 2. Now remember that 1 by 2 is the same value as that of cos 60 degrees. So since cos theta equals cos 60, you can safely write that the value of theta equals 60 degrees. And that is why in this question, option A is the correct option. And remember, we only had to use the values in the question. The only thing that you need to remember is to square the relation. So this relation, we converted it to b bar plus c bar equals minus a bar. And after squaring that, you just apply the value for the modulus square. So modulus values are given, just put them in and square them, and so you'll get the value of theta. So cos theta will be the variable, so getting a value of cos theta and then equating it to a relation that you know will give you the value of theta, which in this case is 60 degrees for this question asked once again in 2002. Let's look at this question. In this question, modulus of A is 5, modulus of B is 4, modulus of C is 3. You need to find the value of the modulus of A dot B plus vector B dot vector C plus vector C dot vector A, given the relation that vector A plus vector B plus vector C equals 0. So in this question, the variable that we need to find is different, so therefore we're going to approach this question a little bit differently, even though we have the same relation. So in the question, vector A plus vector B plus vector C equals 0. So what we're going to do is we're going to square on both sides, so that means vector A plus vector B plus vector C, the whole square equals 0, because the right hand side 0 square equals 0. Now the left hand side can be factorized using this formula, a square plus b square plus c square. So basically it is a plus b plus c the whole square equals a square plus b square plus c square plus 2 times ab plus bc plus ca. This is basically the algebraic identity that you guys have studied in grade 10, so you just need to apply that with the proper vector. So vector A the whole square, we can write that as mod vector A the whole square plus mod vector B the whole square for the second variable and mod vector C the whole square for the square of the third variable. And then inside the bracket which is multiplied to 2, you need to apply the dot product. So a dot b, because here we have 2ab plus bc plus ca. These are scalar products, so therefore you need to put in the dot product, which is the scalar product for two given vectors. So 2 times a dot b plus b dot vector c plus vector c dot vector a, and that is equal to 0 on the right hand side. So now it's just application of all the values that are given in the question. So modulus of vector A is 5, so you have 5 square. Modulus of vector B is 4, so you have 4 square. Modulus of vector C is 3, so now you have 3 square. And then you have 2 times vector A dot vector B plus vector B dot vector C plus vector C dot vector A. The right hand side is equal to 0. 5 square is 25, 4 square is 16, 3 square is 9, and add that to our given sum of dot products, and you will still get the right hand side to be 0. So now what you do is you add all of these. So 16 plus 9 gives you 25, 25 plus 25 is 50. So therefore you can write 2 times a dot b plus b dot c plus, okay, let's erase a bit so that you get the neatness. So b dot c plus c dot a equals minus 50, because 25 plus 25 is 50. Take that on the left hand side, it becomes minus 50. And so therefore a dot b plus b dot c plus c dot a, and when you apply the modulus, you get 25 as the answer. So you just divide by 2 and put modulus sign, the modulus function. So therefore mod of vector a dot vector b plus vector b dot vector c plus vector c dot vector a equals 25. And you know what is given in the question? The question is asking us to find the modulus of the sum of vector a dot vector b plus vector b dot vector c and vector c dot vector a. So therefore the right answer in this question is option A, 25. So here note that we are putting a modulus, so therefore since it's based on the modulus, minus 25 will be incorrect. 50 and minus 50 are incorrect because you haven't divided it by 2 according to our given question. So option A, 25 is the correct option for this question asked once again in 2002. Let's look at the next question. 3 lambda c bar plus 2 mu times a cross b equals 0. Then which of these relations is true? Now from the above relation given in the question, we can write 3 lambda c bar equals minus 2 mu times a cross b. So minus of a cross b will always be written as b cross a. So the right hand side now becomes 2 mu times b cross a. So now the important rule is that for two vectors to be equal, their directions must be the same. So that means both of these vectors must be parallel. So vector c is parallel to the cross product of vector b and vector a. So since these vectors are equal as shown in the question relation, then you can write that equal vectors have equal magnitudes. Equal vectors have equal magnitudes. So that means you can write 3 lambda as equal to 2 mu, because these are multiplied to both the vectors. So c is 3 lambda is multiplied to c, and 2 mu is multiplied to the cross product of b and a. So therefore option B, 3 lambda equals 2 mu, is the correct option. For option A to be correct, 3 lambda had to be equal to minus 2 mu, so that is incorrect. Lambda equals mu is incorrect because you cannot cancel 3 by 2, and lambda plus mu equals 0 is again, due to the same reason, incorrect. So 3 lambda equals 2 mu is the simple answer to this question asked in 2002. So as you've noticed, there are a lot of questions coming from the chapter vector algebra, so do watch out for this chapter and watch more of our videos such as CBSE board exam explanations, as well as more of JEE Main. So moving on to the last question of this episode, we have two vectors given here. Vector A is 3i minus 5j, and vector B is 6i cap plus 3j cap. Now we have a vector C, and the relation is vector C is the cross product of vector A and vector B. So vector C is equal to vector A plus cross vector B. You need to find the ratio between the modulus of the three vectors. So the moduli of the three vectors are arranged in the ratio of. So in this question, the first thing we can do is to find the modulus of A and B. So the modulus of vector A, so the modulus of any vector can be written as the sum of the squares of its components written under a root. So what that means is that for modulus of vector A, you will write 3 squared plus minus 5 the whole square, all of that under a root, and the final value will give you the correct, the correct magnitude. So 3 square is 9, plus minus 5 square is 25, so 25 plus 9 gives you 34. So under root of 34 is the magnitude of vector A. If you look at the magnitude of vector B, then that will be equal to 6 square plus 3 square, the whole root. 36 plus 9 is equal to 45, so under root of 45 is the magnitude of vector B. So from these two findings, you can write that option C and D are incorrect because the values of mod A and mod B are different here. So among option A and B, which one is correct? For that, you need to know the value of mod C. But how do you know the value of mod vector C? You have to find the value, the equation of vector C. So the cross product is now what we're going to do. So in order to find the cross product of two vectors, what you're going to do is you're going to use the working rule. So the working rule for cross product of two vectors states that the cross product, the equation of the cross product, is equal to the determinant I cap, J cap, K cap, A1, B1, C1, A2, B2, C2. So over here, A1, B1, C1 refers to the components of vector A, A2, B2, C2 refers to the components of vector B. So for this question, it will be 3, minus 5, and 0. And the third row will be 6, 3, and 0. So this is the determinant that we need to find out. So you can just expand it along row 1. Now the reason why we're expanding it along row 1 is because you need to get the component. So because of that, you can only expand along row 1. If you expand it along row 1, then you can identify the components. So I cap times minus 5 into 0 minus 3 into 0, and then you have an automatic minus, and then J cap, it'll be 3 times 0 minus 6 times 0. We're just writing it, but from an observation you would already know that I cap and J cap are already 0. So now let's put in K cap. K cap is equal to 3 times 3, then there's an automatic minus, and 6 times of minus 5. So 3 times 3 is 9, minus 6 times minus 5 is 30. 30 plus 9 equals 39. So vector C is equal to 39 K cap. And since you only have one component, the modulus will be equal to the scalar part of that component. So modulus of vector C will be equal to 39. So that means the ratio modulus of A is to modulus of B is to modulus of C will now be equal to under root of 34 is to under root of 45 is to 39. So that means in this question, option B is the correct option. So in option A, the value of mod C is given under a root. That's incorrect. And in option C and D, the values are interchanged, and also some of them are not under a root, right, like they're supposed to be when calculated. So option B is the correct answer for this question asked in 2002. Now once again, I'd like to remind you that vectors is an important chapter for JEE Main because we have a lot of questions asked in the same year. So that means the volume of questions asked from vector algebra is very huge. So for watching more of our useful and interesting content about JEE Main, you can always hit the link in the description down below for the playlist. And to get more of our useful and interesting content like mind maps or NEET preparation, etc., you can always subscribe to our channel Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.